So we have y is x plus 1 over x squared plus x minus 12. So we could write that as x plus 1 over x plus 4 x minus 3. So let's think about when y is equal to 0. Looking at the top, that means that x has to be negative 1. So we have negative 1, 0 as an x-intercept. If x is equal to 0, then y is going to be 1 over negative 12. So we have 0, negative 1/12 as our y-intercept. Looking at the denominator, in this version here, we can see that we have vertical asymptotes at x is negative 4 and x equals 3. We could differentiate to look for turning points, so say u is x plus 1 and v is x squared plus x minus 12. du dx is equal to 1. dv dx is equal to 2x plus 1. So dy dx is going to be v du dx, so that's x squared plus x minus 12, take away u dv dx, which is x plus 1, 2x plus 1, all over x squared plus x minus 12, all squared. So that's going to be x squared plus x minus 12, take away 2x squared. Now this gives me 2x and another x, so it's going to be minus 3x. And then we'll end up with minus 1 all over the x squared plus x minus 12 all squared. So the top gives me negative x squared minus 2x, take away 13 all over x squared plus x minus 12 all squared. Now if we look at the top using the discriminant b squared minus 4ac, that's negative 2 squared, 4ac not 4a squared, take away 4 times negative 1 times negative 13. So that's equal to 4 take away 52, which is negative 48. So it's negative, and therefore this one has no real roots. So we can say that there's no turning points. Now let's look at regions. So our curve is made up of x plus 4, x plus 1, and x minus 3. This one changes sign at negative 4, so we'll look at x is less than negative 4. This one changes sign at negative 1, so we'll say x is more than negative 4 and less than negative 1. Just to explain that, think about x plus 1. If x is less than negative 1, this thing is negative, but as soon as x is more than negative 1, it's positive, and when x is negative 1, it's 0. And that's what I mean by it changes sign at that point. So we just look for where the expression is 0. This one changes sign at 3, so we'll look at x between -1 and 3, and then we'll consider when x is more than 3. And then the whole point of doing that is to see what happens to y, which is made up of the three things above. So they're all negative here, which means this one is negative. This one becomes positive. This one's still negative and negative. So overall we get positive. Then we'll have positive, positive, negative, so overall negative. And then finally they'll all become positive. So overall positive. So we're about ready to do our sketch now. So x-axis here, y-axis here. Our asymptotes are at -4 and at 3, so those are vertical asymptotes. So x equals -4, x equals 3. We know that we have an x-intercept here at -1, and the y-intercept is at -1/12. So let's look at what happens in this region here. So we know that y is negative, so we're going to be below the axis, and it's going to go off along the asymptote, and then as x gets larger, more negative, the bottom's going to be much bigger than top, so we're going to tend towards 0, so it's got to do that. Let's go for this region over here. It's positive, and the same sort of analysis tells us that it's going to do this. Now, between -4 and -1, it's positive. When x is close to -4, the denominator is going to be close to 0, so it must go up here. It's going to come down, it's going to go through here and here, and then it's negative in this region, so it's got to go off along the asymptote, like so. So this is y equals x plus 1 over x squared plus x minus 12. Here's an accurate plot of the same function. We can see the intercept here. We can see this intercept is not quite at the origin here. Difficult on this scale, but if you zoom in, we can see the two asymptotes. We've got this section of curve just here. On a sketch, it doesn't matter if you don't get it really tight in like it is here. And the same thing over here. It doesn't matter if you get it really tight in. The important thing is that you show the features of the curve going out along the asymptotes, horizontal and vertical, and here as well, and you actually show the intercepts.